Right. So what I'm doing now is I'm bringing up the slide for chapter number 7. Start from chapter number 7. The textbook content become rather technical. As you can probably see that I'm at near end of the chapter. It show you some sort of store procedure or trigger of some kind that seems to be very complicated. But don't be kind of intimidated by the complexity. Let me try to give you a higher level view of what we need to know as a master level student in terms of the codings and technology required for this part. So chapter 7 is kind of continue to introducing SQL language, but it will be the language part that I do not want to emphasize, but I do want you to know that there are certain components of the language. First of all, just kind of review what the SQL language is. It is actually a complete set of language that allow you not only to access database, but has the ability to manage the database through any different interfaces. All right, so the whole purpose is we are trying to creating a standard or some kind of protocol. So regardless what platform or what kind of database management system you are using, you can always use this set of language. And if other system, programming language system or operation system want to talk to the database, they can also talk to the database through the same interface. So in order to achieve that, there are many standard set of requirement in the language. These include terminology here: DDL, DML, SQL, PSM, TCL, and DCL. Right? So all five of them. So far, you have been exposed to the first two categories: DDL, definition language, and DML. Whenever you are trying to create a table or actually using our script to recreate the database, and you have done that several times already, and including when you import an Excel spreadsheet, the database engine is actually using the DDL try to create the table for you, and you can execute the script, or the script will be automatically generated by the wizard. And for the select statement, that you are actually using something what we call the data manipulation language. You are retrieving data from the database system, and we also have used in the script as well the data script using the insert. It's just that we never go into detail to take a look at how this language is used. Now, these understanding of these language are particularly important for developer, and I believe most of you are will not become a developer in a database or in any environment. Some of you might, some of my former student and still keep maintain the connection with me, and over their career path, and some of them uh, turned into a more technical person, and they been. I think last time I mentioned I had a student graduated in 2013, I think 13 or 14, and he was originally working as a data analyst in Chicago, but now he worked as a more like a developer for links in San Francisco. So he has changed or kind of over his career, starting from the database and learning more and more and going to that career track. So, but yeah, once in a while I talked to him that he told me that he regret he cannot learn more when he was a student here. But it's just it's always the case that you have limited time. That they have so many courses and priority in your life to take, so that cannot blame. So, but getting some understanding about what are the component for the language are important. So here we are. So the first two part, and the first two part are probably the part you will be using the most, as assuming that you're going to be either uh, as a database administrator, well, you get into a more technical position, or just simply as a report writer, a person doing data analytics, or in the future, some of you may be involved in the AI field. AI is not as hard as you think, and as long as you know what package and what software to use. And so, but any AI language or AI machine or package, AI in Python or R language, you always need to connect your engine to a data. And traditionally, this data language will be the one you use, and most likely will be using these two. So data definition language and data manipulation language. So data manipulation language is particularly important because you have a select, insert, update, delete will be used together by other engine as well. The data definition language is not that important from my teaching perspective. The reason being that a lot of these functions, creating table relationship or creating structure in data definition language can be achieved through a graphical user interface that you use either in Oracle environment, a SQL developer, or you can use the Microsoft SQL Management Studio to achieve the same purpose. So without knowing that language, the definition language, you can still kind of navigate yourself inside the SQL world. The persistent store module or the SQL procedure language is the language or the structure enable that you write programming like language, even though SQL was originally not designed as a programming language. But when people use SQL more and more, they kind of desire this kind of capability. So certain actually very powerful programming feature has been built into SQL. And what I intend to do is the textbook give you some example of using the textbook data set to test some of the store procedure. And my job, or actually I've been doing this in the spring, but failed to do so, is I'll rewrite those programs and put them into the Apex environment to show you how those programs can be used. Simple examples, so you get exposure to what they look like. But this assignment or the tutorial will come in later when you are working on your project assignment. You just play around to get exposure to the programming feature. And then the next component of the language is transaction control language. And these languages are usually that covered in the learning of a particular DBMS. Oracle has their own TCL. SQL Server has their own TCL, and it's some of the language actually it was already used in earlier tutorial in a semester when we try to use some sort of a command line communication to the server, and that is when you are using that transaction control language. And this will be introduced a little more in I think chapter 8 and chapter 9, chapter 9 when we are going to be talking about the concurrency issue. How do you control the performance of a database management system? And finally, you have this data control language. It's actually the user management. And in the past, I have an assignment of user management early in the semester, but in this semester, I decided we're going to be moving to 2 weeks from today when we introduce chapter 9, and you will have a Oracle user management sort of like exercise assignment and play around with the privilege and the permissions, that sort of privilege and roles of a particular user. And actually, if you start working on assignment number 8 already, that's in the Apex environment. The Apex application development in that particular exercise, I ask you to create a user, and you have to somehow make the user accessible to the application and the data set you created. So that give you a little idea about how you manage user. And of course, the complete user management is covered or actually discussed in in a more technical class, especially when you introduce the network communication. And I know that in our curriculum we have a network communication class, but it does not cover the complex issue of different platform. And there are issues about the user you created in operation system, Windows or or Unix or Linux, compared to the user that you created in database management system, and how do you sync them together, or passing one user from one system to another. That's another issue that we usually will see that in the network communication environment. Right? So that's pretty much it. So the rest of the lecture will be pretty dry and boring, right? So just relax and stay with me, and let's go through the slide together, and that will kind of put your attention on the right place. And if you really feel tired, go grab a cup of coffee or something and come back. And you can always watch the recording, as I mentioned earlier. That's good. So the case we're going to be looking at is the view rich gallery case. We use this case to look at how the language, the SQL language, is used in all different aspects, from definition language all the way to, I think, the store procedure, persistent module language component, but not introducing the control language. So, and this is a small operation, and the data structure of this particular case is very interesting, right? But let's take a look at what this particular application is trying to do. And it is an application try to process or handle some sort of transaction. Now, one of the training when we are looking at the requirement of a database system is that if you recall that when we are working on the data model, I keep emphasizing that you have to know there is a pattern called the line item pattern, also called the transaction pattern. So that line item pattern is the core of almost all the transaction processing database system we'll be using, because almost everywhere that we create a database to keep track of transaction. So when you are looking at the requirement or the functionality of this little database application or any application, you pay your attention to transaction. So where are the transactions on this particular table then? Second one, record the gallery's purchase. The third one, record customer's purchase. And the fourth one is kind of derived from the first and the second and third one. And you have the fifth one says, or it's actually artist is not a transaction. And the next one, the inventory, it seems to be like a transaction, because inventory, you have to add inventory, you have to remove inventory, that sort of thing. So look at this is a typical buy and sell operation. Requirement number 2, buying. Requirement number 3, selling. And buying and selling are two transactions. So if you want to build a data model or actually look at how the data will be kept in the database, it should be a table is either called buying or selling or something. And in this particular database, they design the database in this way, right? And over the last week or so, when some of our students are working on the ER model assignment, and the question keep adding up, or actually I received a few questions asking me about should I assign the foreign key to the assignment when you are drawing the ER model. The answer is no, right? So if you haven't worked on the ER model assignment yet, that the answer is no, you don't need to. ER model is considered to be something what we call conceptual model. When the ER model going to be implemented in the database environment, you have to do some sort of conversion process. In that conversion process, you have to make a decision. And in the next few slides, you will see how this particular model is implemented in the Microsoft environment with the foreign keys assigned, right? So, but in here that they have marked the foreign key with this parenthesis, so you can see that. And so let's take a look at this model a little bit before we move forward. And the most important part, if you look at the this particular model compared to our transaction or line item um, pattern. The immediate thing I hope you can find is that the table called TRNS or transaction should be the most important one because that will be the middle table there. And the participant of this particular transaction will be the artist and the customer. But unfortunately, the structure is different from the line item pattern. So what they are assuming here is they do not have line item. I don't know if you can see that. They what they are trying to say here is every transaction in this particular operation, you can every time you buy something, you can only buy or sell one item, right? So that's one. Second thing is that this transaction cover both buying and selling operation in the gallery, in this particular gallery. So they do not differentiate from buying and put them into inventory and selling and create a sales invoice or record. No, they put both buying and selling into the transaction table. Now, which one is better? This one is actually okay for the small operation. This is a small gallery. If you look at the assumption of the case, so it's okay here. But if you want to handle a more real world situation, then you probably want to use a line pattern as well. Right? So that's one of the observation we have looking at this particular data structure. And the other important thing about the data structure is that we emphasize a lot on ER model when we look at the relationship. And some of the relationship are called ID dependent. Some of them are not ID dependent. Using again Microsoft Visuals or Microsoft language, we call this ID identifying or non-identifying relationship. So solid line are called the identifying relationship. Dashed line are called the non-identifying relationship. So when we have a non-identified relationship or non-ID dependent relationship, the entity on two sides will be the strong entity, right? So that leads to how you define what is weak and strong. And the focus I want to draw attention to here is between artist and work. So if you look at artist and work, right, imagine that you're going to be running this gallery. So you're selling this print or selling this the replica of the original artist's work. So a particular artist, say Van Gogh or Picasso, right? Van Gogh, Picasso, they must have a lot of work. So if you look at the relationship between artist and work, then in this case will be say uh, using our human intuition, the work should be a weak entity. Does that make sense? If I make this particular statement, I don't know if that. I hope you feel like that makes sense. That if work is weak entity, work is weak because if you do not have artists, there's no work, right? This is kind of like the example we use in from the textbook. If you do not have a building, you cannot have an apartment. Apartment cannot exist without a building. So in this case, work cannot exist without artists. And so translate the weak entity concept into ID dependent concept, then this line between this line is right here, right? My cursor is moving here. Created or created by relationship should be a solid line. That's called ID dependent, right? But instead of a solid line, what you see here is what? A dashed line, right? So that the question is now, why is that? So based on our on the based on the intuition or the regular common sense, your professor give it to you. This should be a solid ID dependent line. But why become a dashed line? Dashed line means both sides are strong entity, right? The answer being that this is not, by the way, written in the textbook, but it makes sense actually. I thought about this for several years already, and that the work they are selling here in this particular gallery, and of course we didn't read the case in much detail, is actually not the original work. It's actually the replica of the original work. So it's a print. So you kind of take a picture or ask another artist to recreate the painting. So the say for example the Mona Lisa, right? So if you have a work of Mona Lisa, everybody know Mona Lisa, so that's why. So Mona Lisa. So and if you look at the attribute of this work ID or work entity, there is an attribute called copy. So they are actually talking about how many copy, the copy number one, number two, number 100, number 1000. So they are not actually selling the Mona Lisa per se, but they are selling a replica of Mona Lisa painting in this particular case. So the work is actually, well, in this case, independent of the artist already, right? So that is their judgment. But there are also other consideration in the real world implementation. Um, the other consideration will be that if you have an ID dependent relationship in here, what if you discover an artwork that does not have that does not have the information for which artist or who is the artist create this particular work, and because someday you kind of open up a tomb from Egypt somewhere, and you discover a magnificent painting from 3,000 years ago, and you don't know who painted and how do you create that work. If you make it ID dependent, you cannot create that record in your database anymore. So this is another kind of practical reason that they make this non-identifying or non-ID dependent relationship instead of a dependent relationship. However, the line or the relationship at the bottom of the model, you have this customer artist intersection. And this is actually a table they try to create uh, pre big data era, pre AI or sort of like a artificial intelligence, machine learning era. That we try to create some sort of a customer preference. So this business situation here is that if I have a table keep track of all the customer I have, as a owner of an art gallery, I might want to know the taste of a particular customer, so I can tailor or create customized promotion to that particular customer. So if I have a new painting or replica coming to my gallery, I know this person say may like that particular style of painting, and I'll just push those promotion to that person. So in order to provide this customer relationship management, they create this customer artist intersection table. It records the interest of a particular customer to a set of artists. So the relationship between customer and artist are many to many, translating into two one to many relationship. Right. So that's how this particular data model is created. So it's a five table model, but it's actually very interesting and has a lot of detail that can be discussed from the database design perspective. Right. So now you can, of course, that find the data that I'm going to be showing to you, or the script, the language we are going to be looking at from the textbook supporting site. So if you go to their textbook supporting site, Pearson Higher Education / Cronkey, and you will be able to find the data set. It has data set for I think 5 different platforms: Oracle, SQL Server, MySQL, Excel, and Microsoft Access format. Right? So there are like 5 different format. You can download and keep a copy and play around that environment. Right. So do go ahead and take a look at that database, because we're going to be looking at them here. And I'll compare and contrast a little bit between Oracle and SQL Server, so you get a sense of their differences in using this language. Right. So what other language that use in these script or the data files that you'll be downloading from the textbook website then? Including data definition language, this include create table, alter table, drop table, and truncate table. And you already probably know what create table is. It's very intuitive to know alter table, and later I will explain in the next few slides about drop and truncate, and those are two different operations. And some of you have used drop already, and in the Apex environment because you need to free out space, and we will look at the interface a little bit later. And of course, you have this manipulation language. You have done select extensively, and other than select, you have insert, update, delete, and merge. Merge is a special one. We're not going to be playing with it because a lot of time merge is performed through a stored procedure or through a programming language, and that is another another kind of interesting combination between programming world and the database world. Right? It's kind of people use the whatever they feel like they feel comfortable and to you select one function from SQL language and probably do a lot more calculations and data validation in the programming language, and vice versa. It depends on how you are trained. So if you are trained mainly from the database world, you will tend to use the SQL language more. But if you're trained from more computer science world, you will tend to use the programming language, C, C sharp, Java, or any other language to perform the same operation we're doing here, right? And you also have already see some of the example that I showed to you using Vue to simplify your algorithm or the logic in order to create a better report. So I hope that you remember that part of using Vue and to create customized report. That is actually very helpful. And a lot of time as a database administrator or as a data analyst person, you don't really need to kind of play with programming because I know programming is actually very problematic. When you create a program, they will tend to have some logical error you may or may not discover, and those become a loophole later that other people can either hack into your system or actually create data quality problem from using a wrong or not so well designed computer program. Using SQL language has a benefit of because behind the SQL language is supported by the database management system, supported by the large company Oracle, IBM, Microsoft. The algorithm of executing these commands is already being perfect, so that is more reliable source of actually performing job. So using Vue and SQL language to create the step-by-step logic is better than writing a program or writing a stored procedure to do the same job. I think that's my key point here. And of course, you will see some example of function, trigger, and stored procedure in here. And this is just a screenshot of Management Studio from Microsoft, and you have seen that already. The structure of create table is simply as create table name and so on and so forth. And there are options about each column and constraint you can have. And these slides, I kind of go through them very quickly because we're going to be looking at the real example from the from the coding from the script that we going to be opening up on my computer desktop. Right? And there are some constraints based on the database implementation from the chapter 6 you see earlier. We did not discuss this in much detail, but I think this is more or less more intuitive. So you're looking at every column, you convert attribute to column, and column need to have a name, you have to assign data type, you have to assign their key property. It's either primary key or alternative key, nullable status, or some other constraint that you put at the end. Right? So once we know that, we can actually try to implement that constraint, all these constraints, into a language like this. So this is a create table from Microsoft SQL environment, right? And let's kind of take a quick look at the language here. Create table, easy to understand. So we create the table artist. Each one of this row here, line here, represent a column. So artist ID is a column, last name is a column, first name is a column, nationality, date of birth, and so on and so forth. And the keyword constraint, the blue word constraint, you create a constraint for that particular um, table. In this case, we have created two constraints. One is primary key constraints called artist PK. You assign artist key PK as primary key. The other is called the alternative key constraint. Basically, the alternative key constraint is make sure that we have an alternative key that to be included in the table. And there are practical reasons of identifying alternative key. I don't know if you remember, if you are working on normalization, alternative key can create BCNF problem, right? Boycott normalization form problem. And you try to eliminate or actually avoid alternative key, especially multi-column alternative key. But in this case, you see that we have created a multi-column alternative key. What does it mean is that we want to make sure that in our database, the artist is unique, not only in their artist ID. So every artist has an artist ID, but we also want to make sure there are no artists has the same name, right? But it's likely you might have a father and a son, and both of them have the same name, and both of them become artists, and they have different work. They don't even use the senior, junior postfix. But in this operation, they assume every artist is unique in their last name and first name combination, right? So what they are trying to say here is this last name plus first name together, right? So not individually, together is unique. So this unique is a keyword. And so another kind of interesting thing here is that in data definition language, there is no such thing as alternative key keywords. Alternative key keywords actually enforced by this keyword called unique here. Right. So this is a Microsoft version. Let me exit the slide and show you the program that actually capture the differences between the Microsoft and the Oracle version of the same code. So on the left-hand side of your computer screen here is the Oracle database SQL code solution. And the environment I'm opening up here is under a Macintosh computer. I'm using a code editor to display the code. So it's probably uh, looks different from the SQL developer or Microsoft Management Studio environment. But I enlarged the font size so it's easier to read. So on the right hand side here, it's the Microsoft SQL Server 2016-2017. So this is the script that you see from the slide, but adding a little more constraint. These a little bit more constraints are nationality, and so they create a set. It's called check. So you can check nationality in certain keywords. Canadian. So there are only one, two, three, four, five, six, seven, eight different countries in the collection of the artists for this particular gallery. You can, of course, later modify the constraint to add more country in there, but that this is actually not a very good way to do it. Uh, so let's keep that way here. And you also have this birthday or age control sort of a constraint. There's no such person can have the birthday die before they are born. So that's kind of a understanding. The constraints like this are used to control data quality to make sure that when you input data or entry data into the database, the data are consistent in the real world. So that's the Oracle, Microsoft environment, and this is the Oracle environment, right? And it's quite long, so I will tell you the differences between these two. The main difference between these two is lies here. Lies here from line 16 of the Microsoft script. Line 16 on the Microsoft script says artist ID is of course, required, so it's not null in terms of property. But it does have a function there that says identity. This identity indicate one important concept we learned from previous chapter called the surrogate key. What is a surrogate key? Surrogate key is an artificial key, usually consists of a number or number plus some sort of a letter number combination. But we usually use some sort of a mechanism to make sure these numbers are unique. So there will be no duplication. So because the surrogate key does not have duplication, the data consistency is usually better. And so modern database will automatically assign a surrogate key to any table you created. But in this case, that we have artificially assigned artist ID as a surrogate key, right? Surrogate key, and the keywords or the function used to generate that key is identity. And what does this identity mean is that I'm going to be creating a number sequence. Right? I'm kind of using the term sequence here because Oracle calls this sequence. And the first number one, and you see that there are two numbers within the parentheses of identity, one and one. The first one says this particular sequence of number will start with the integer number one. And the second one is saying that every time you create a new record, the indicator will step up one more. So the sequence of the number will be 1, 2, 3, 4, 5, and so on and so forth. So if you have an identity 1 and if you change this to 1 and say 10, oh, lock, 1 and 10. So if you change to 1 and 10 here, this will change from the original step 1 to step 10. It means that the number sequence of this identity or the surrogate key will look something like 1, 11, 21, 31, 41, and so on and so forth. So that is the mechanism that we create surrogate key usually in a typical Microsoft environment. Now, in the script example of Oracle script, they do not create this particular surrogate key, and they actually enforce this in their program, which is a bad idea. The let me unlock this. In the Oracle environment, the function used to create it's not actually not add up here. It's actually add up to another line here. You will create a sequence. The keyword is called sequence, and when we have a change, I'll show you what the sequence look like. So sequence is the keywords that we are using in this particular environment. Now in the Oracle environment here, and here of course is Oracle Apex environment. It's a dark background. You probably see a brighter background, but it really doesn't matter. If you go into the SQL workshop and if you look at the object browser here, and the object browser gives you some indication of what kind of object we have. If you click on the list, you see that first one is table, you have view, index. The fourth one says sequence. Sequence is the one that used to create that surrogate key. You can take a look at there in our demo. There are some sequence being created for different tables. Say, for example, you can take a look at the customer sequence, and the sequence does not have really data. It just said the minimum value is 1, the maximum value is infinite, and every step incremental is 1. So it's equivalent of identity 1 and 1. Right? So in this case, so this is my Oracle sequence, and in the Microsoft it's called identity. Right? So that is something that draw your attention to. And the foreign key is enforced. Take a look at the work table. And later we'll see this in the slide one more time, and we'll take a look at how they are similar or different in that environment. So foreign key is defined using so-called constraint. I'm just highlight the constraint. So when we use the foreign key, so now we are learning 3 different constraints already. primary key constraint, unique constraint, create alternative key, and foreign key constraint, foreign key. And from the language structure itself, this name can be anything. It's user assigned name. This is the keyword. Foreign key is a keyword. Unique is a keyword. Primary key is a keyword. Right? So, and it's the same between Oracle and Microsoft. So when you create the foreign key constraint, the something called referential integrity constraint will be enforced. And in this case, the referential integrity is enforced using something called a reference. So they use the foreign key and reference to create a constraint that you learn from chapter number 6 to enforce different kind of insert, update, delete. So when you delete something, do I delete the parents or do I cannot forbidden you to delete the parent? That sort of operation. So that is the thing we learn from the difference between these two environments. Right? So switch back to the slide here, and you can see that those kind of a program keywords here are highlighted with the blue words here, so you can much easily see how they are enforced in different environments, right? And there are, from your textbook perspective, that they have introduced many different situations, and I choose not to lecture one at a time because these when we introduce example to each one of them, we will create a very long recording for one, and it can become quite boring. But basically, that you learn that we are going to be specifying this foreign key keyword in the constraint and a reference keyword to enforce the one-to-many, one-to-one relationship, especially when you have this required relationship. I remember that in ER diagram we have option and optional and required, and when you have minimal required, you have to enforce usually the requirement in the database environment. And the requirement as a developer can be enforced in usually two places. One is the in the database management system. The other one is you can always enforce in an external database application. Right? So the term application layer and the database layer, data layer, application layer, the same job can be performed. Right? In this case, we're enforcing some sort of relationship control, minimal and maximum requirement control, and the control can be enforced at both application layer as well as database layer. Again, it's the option of the system developer to decide it on which layer you want to do. The recommendation is always, if you are using a relational database, try to enforce this at the database layer, because database layer has a higher performance. Their algorithm have been optimized to perform data operation better and faster. Right. So more complicated. This is actually the one that you see in our example that earlier here. So a few more examples. We don't need to go through all of them. They are relatively similar. One thing, however, can be kind of take a look at it here is that from this is the intersection table. This is the weak entity or ID dependent entity we have seen in this data model. The reference, the main constraint that differ this one from the previous one is the reference enforce the one-to-many relationship here is visible and explicit here. So the reference on update and on delete means that you need to enforce that particular referential integrity, which means that when you are creating a record here, you cannot create a record that does not have the artist name or customer name not in your database. Right? So that is basically what they are trying to say there. And finally, that from the data definition language perspective, many environment, including Microsoft, and this is Microsoft Access, they have this reverse engineering capability and implement your database in this model. This is actually it's an automatic feature in Microsoft Access. This diagram, however, is not called ER diagram. And be careful that you look at the title, it's called the database diagram. And actually, I believe the official name from Microsoft, if you look at from the VCO environment or from the Microsoft Access environment, they call this diagram relational diagram, relational, not ER diagram, relational diagram. And because they show the implementation, the key. And one to many is represented by this weird infinite notation, the many sign, instead of the crowdfoot that we are using in ER model. But this is the model we use. Right. So that will be, I think, well, not yet. We're going to be looking at the create table, and this is outer table. Outer table is also useful in a lot of our operation, especially when we try to move the data from one database to another database. And the keywords we need to learn here is add and drop. Right? So in database language, add and drops are similar to add, insert, and delete. Right? So we don't use the term delete here that much. Instead, we're going to be using drop. So drop means that in data definition language, either drop a column or drop entire table. Right, so that is pretty much the main difference. And you can drop column, you can drop constraint in the process or in the data definition as well. Detail, again, I will not bore you too much because everybody can read the detail there. And we don't really need to test all these, but just try to understand this. Again, as I mentioned that we need to know them, but since we're not developer, we may not use this as a programming tool. So we'll just kind of appreciate and know what they are, be good enough. So remove table using drop. The other one that we have is called a truncate table. Truncate table is we are not deleting the table. Truncate is delete the data inside the table, but you keep the table. So pretty much you create actually not necessarily empty. Sometimes you can truncate part of the table, not entire table. But usually you truncate the entire table. So you delete the data from the table, but you keep the table. That's called truncate. And the drop is you drop the table altogether. Next time you need to use the table, you have to recreate the table. So that's the main difference between them. And truncate and drop and truncate does have its a limitation. Sometimes you cannot drop or truncate because especially when you have a weak or you have an ID dependent relationship, you cannot drop or truncate the parent because you drop and truncate the parents, the weak entity cannot exist. So you cannot do that without deleting the weak entity first. Right? So that is actually a lot of error message you will encounter when you are trying to delete the table in the database environment, and you cannot do that. And in the Oracle environment, the drop and truncate can be seen very easily. Say, for example, if you have a table in your Apex environment in the object browser, you want to drop and or drop or truncate a table. You can, of course, always go into the SQL command environment, SQL command, SQL workshop command environment to enter the statement using drop table or truncate. Or you can simply use this drop and truncate option here, right? And of course, you have to be very careful because once you drop the table, and they usually will ask you to confirm. I don't want to confirm it. Then you're actually dropping it. And the environment like this one, this is very similar to SQL Developer, even though this is a SQL Apex environment. This type of environment always will tell you what SQL function or SQL statement they are executing. So this, when I click on this drop button, you open up the SQL, you see that the SQL actually was executed is here, drop table inventory. So that's a lot of time that as a more experienced database administrator, you will double check because sometimes the engine like this will issue the wrong statement. And later in the user management, we know that some of the same functionality of assign privilege and permission to user can be performed by multiple keywords. Say, for example, alter that we're going to be learning in the slide, as well as a grant privilege, or use grant or alter. Both of them can achieve the same thing, but with different procedures and a different level of authority. So that's something that might worthwhile to pay attention to, right? So back to the slide. So now we learn the difference between drop and truncate, and to make sure that you differentiate them uh, well. And this is a very nice exam material. I'll probably ask you to answer that question in there. Right. So create table, alter table, drop table can also be used in create index, alter index, and drop index. Index is another object that we usually use. As you can probably see, this is a pre uh, NoSQL, pre-data, pre-big data era. We usually create index to improve database performance. Index is kind of like a primary key. Whenever you create an index, you actually sort the table one time. And without explaining too much, let me tell you the most processing intensive operation in SQL language is sorting. So when you try to sort the data in database, you are moving data from one row to another and try to sort the data will create both processing constraint or actually load as well as memory because you're moving physical record from one place to another. It's actually very time consuming and so how do you sort the data without actually physically sort the record? The answer is using index, right? In modern database, most of the modern database will automatically index every column. So you a lot of time we don't really need to explicit create index anymore. But some people will still try to create index to make sure that the the program you create, the application you create, is backward compatible. Right? So that is the data definition language from chapter number 7. And now we'll stop here for the first segment of the recording and move on to a more, well, you can call this advanced level of the database or SQL language.